It's 4 o'clock in Germany, 8 o'clock in Costa Rica. Dear audience, I'm so happy to have you here. Dear hydrogen fans, dear Mission Hydrogen and H2 mobility fans. Yes, today we have a great show. We have the heavy duty transport and infrastructure show. Together with H2 mobility, we will bring you in the next about 60 to 90 minutes. Normally we send 90 minutes as you have a lot of questions, and I'm pretty sure today you also have a lot of questions because we have a really huge number of people here, in over 600 at the moment, but I'm pretty sure we will be more in the next minutes. Before I welcome the H2 Mobility team here on the virtual stage, I will tell you who we are. Mission Hydrogen brings this webinar together with H2 Mobility today to you on the desk. Hey, Oliver Schneider, that's cool. Ja, wir haben Fragen. Yes, we have questions. That's pretty cool. You can bring that in the chat. And in the meantime, by the way, you can post, as a lot of people are doing right now, where do you come from? I'm pretty sure the world is in here today. Tell us from which country, from which town you are coming. Mission Hydrogen, you can connect with us on LinkedIn, Twitter, you can connect with myself, and I'm really happy to have you as a follower, and then you can follow us in the next weeks and months, because we will bring you the latest news on the desk weekly with our webinars, and also in October. Our webinar series is a series that runs the whole year 24/7. We have gold sponsors, for example, Burkhardt Compression, Hexagon Purus, and Neumann und Esser. Thanks for your engagement for this great future topic. And if you also want to be visible as a sponsor, you can connect with us. If you have missed a webinar, or if you do want to have the whole 120 plus hours knowledge straight on your desk, 24/7 access, then you can have a look at it online. We have the 2020 collection, and we have the 2021 collection, and also this webinar today for sure will be in the collection afterwards. There you go. This is pretty cool. Slovakia, Australia, Italy, Chile, Japan, India, Bavaria, Hamburg, Denmark, California. So as I said, the whole world, Malaysia, the whole world is here today. I love it. And I do also love the HOC. The Hydrogen Online Conference will come to you again. The second edition will brought to you by us on October 8th. We will start at the European midnight and then run 24 hours around the globe, as our partners that you can see here also are supporting. You can get your free live ticket right now. My team is posting you the link in this seconds, and then you can click on it and you are in for free. If you want to show yourself, your project, your company, we have something new. You can now book a poster. This is not for free, but for less money, and you can tell the whole world, 10,000 plus people we are expecting on October 8th. You can tell them what you are doing, and you can sell your idea or your product. If you don't want to have a booth because it's too big for you, for example, or you want to have both, this is also no problem. And our happy sales manager, Irma, can bring you on this list. This is the list of the exhibitors right now. We have number 50 at the moment, and we are expecting 100. So you can book it right now, and then we will reach the 100 plus exhibitors. Your way to meet new customers. And now I'm finally done with my first slide before H2 Mobility is coming, by the way. We have two booth types, classic or corporate, and you can discuss with Irma which booth type is the best for you. Or you can become a sponsor, bronze, silver, gold, or platinum, and then you also have a booth included, and you are visible from now on with immediate benefits. There you go. And last but not least, the last slide from my side here before the real show is coming to you. benefit from your membership. 20% off if you are a member of a hydrogen association. Worldwide, federal, state, doesn't depend. All countries, you will get 20% off everything at Mission Hydrogen. This is my gift for you today. And now I'm bringing to you the slides of H2 mobility. And I'm now asking Erin. Erin is your moderator of today, and I'm asking her to come to me on the virtual stage. There she is. Dear Erin, I'm so happy that you are now taking the place from me, and the virtual stage is yours. Welcome.
Thank you so much, Silke, and welcome to our audience. Welcome everyone to the Mission Hydrogen webinar with H2 Mobility. Like Silke said, my name is Erin Udecke, and I'll be your moderator for H2 Mobility's live panel discussion of the overview, Hydrogen Refueling for Heavy-Duty Vehicles. The overview is available for download from H2 Mobility's website. That is h2-mobility.de, and the link has been shared in the chat, so feel free to follow along. All right, so we're all here today because we're interested in a collective clean energy future, and the mission of H2 Mobility is such to demonstrate that hydrogen mobility for mobility and hydrogen for transport works by building and operating a national network of hydrogen refueling stations in Germany. Currently, H2 Mobility is preparing the expansion of the hydrogen refueling station infrastructure for commercial and heavy-duty vehicles in all vehicle segments to lay the foundation for long-range, emission-free mobility. In the first half of the panel discussion, we will meet 3 H2 Mobility team members who will share their expertise and knowledge. And then in the second half, we will transition to a Q&A discussion with the team. So that means we invite you now to write your questions in the chat and throughout the session, and we will answer as many as we can at the end. With that, let's meet H2 Mobility. I'm honored to introduce you to our speakers. First, Nicolas Ivan is the CEO of H2 Mobility Deutschland. He joined the company shortly after its foundation and has been leading ever since. Lorenz Young is Chief Projects Officer at H2 Mobility, and over the last years, he and his team have established the network of H2 Mobility Deutschland hydrogen refueling stations that are currently in operation throughout Germany. And lastly, here is Nora Oberlander, an industrial engineer and business strategy professional. Currently, she contributes to the strategic development of H2 Mobility and adds experience from strategy consulting and the renewable energy sector. Welcome to our speakers. Now, of course, we would like to get to know you, the audience. We've asked a question in the live poll, which you can answer now. And that question is, what sector do you represent? So please send your answers in the poll now. And while we are waiting for all of your answers to come in, I'd like to address the first question to our Nicolas. So first, Nicolas, simply, why are we talking about hydrogen refueling today, and what role does hydrogen play in the shift towards zero emission transport? Why are we using hydrogen for heavy-duty vehicles?
Well, thank you very much, Erin, for the introduction, and Silke as well for the welcome. Amazing how many people have dialed in here, and I'm really looking forward to engaging with you in the next 80-90 minutes or so. So first of all, I think it's very good that so many are talking about hydrogen at the moment, and that we also have the chance to go a bit deeper into this very current and important topic of hydrogen refueling for heavy duty. There are many good reasons why hydrogen will play an important role in the energy transition. So hydrogen is an important vector to transport energy actually and bring it from the places where it's cheap and abundant, where it can be produced, to other places across the globe. So there are many generic reasons, let's say, why hydrogen is a good idea, and very specific ones for the deployment and transport, especially for heavy duty. So, of course, it's a zero-emission fuel, and it comes with high energy density and the speed of refueling. So I think those are probably the most relevant. Therefore, hydrogen allows refueling speeds of several thousand kilowatt, if we express it in the language of electricity, let's say. So it's very fast, and refueling times can therefore be similar to today. Plus, of course, the moderate weight of the hydrogen drivetrain, which is important when you want to optimize your payload and when you operate heavy vehicles across larger distances. So those are a number of reasons why hydrogen, I believe, will play a very important and even major role in the heavy transport sector in the future.
Great. Thank you so much, Nicolas. That's a great summary of an incredibly thorough topic to cover. So now I see that the poll results are in, and it looks like so many people are joining us from different sectors, all for this clean energy future and for this zero emission technology. It looks like about 18% of our audience is representing an OEM. 1% are coming from an IOC, another 1% from IGC, wow. Another 9% represent a governmental agency, great. And 36% are joining us from a supplier. Okay, and last but not least, it looks like 32% are also joining us from other fields, other sectors. So we're all here from a diverse variety of backgrounds, but for this clean energy future. And speaking of backgrounds, so Nicolas, again, could you tell us who is H2 Mobility? What is the role of H2 Mobility in enabling hydrogen for the future?
So, first of all, let me say that I'm very happy to see especially so many participants from OEMs. So I assume those are people who work for truck and car manufacturers. It is an eternal discussion whether the supply side or demand side should step up their game. In Germany, we have built, some people say, the highest number of stations per 1,000 vehicles. So we have pretty much a demand side challenge here. We have created a supply. Now we need a lot of demand to continue with the supply buildup. Therefore, I'm happy that many OEMs are participating here. So who is H2 Mobility? To put it in simple terms, we are a company. We are based in Berlin. We have built over 50 stations on our own, and we operate today more than 90 stations, and we do support others to do that. Mm-hmm. We are also a group of 45 passionate experts. We want to make a contribution to the energy transition, to making it a successful transition, and we believe that hydrogen is a key ingredient, let's say, to solving the defossilization challenge we all face. Our role is to be a key enabler, actually, to foster also the discussion and the distribution of knowledge. That's also why we are here in this webinar, to accelerate the widespread use of hydrogen in transport. So we all believe in that as a clean fuel, and we want to play our role as an enabler. Therefore, we are talking today.
Great, great. So it's very clear that, like you said, H2 Mobility is an enabler. And looking back at this enablement, Lorenz, what has been H2 Mobility's track record? What did you need as a company to be successful?
As Nicolas mentioned, over the last years, we had a very steep ramp up in rolling out the HRSs, or the hydrogen refueling stations. And so we had the largest amount per year worldwide brought into our network. And being successful in that way was only possible because we had a very skilled and diverse and trained team and highly motivated. That's probably one of the key facts. But not only ourselves, it only worked because there were many partners with us that worked together. And so the track record, the bare numbers are more than 50 stations implemented, more than 90 stations in operation. This also includes stations in Austria. And this means from the scope that basically from scratch, from finding the right concept for the stations all the way via planning, permitting, construction and commissioning until operation. And then even it goes further in optimizing and doing the maintenance for the stations. So this has been covered over the years. And of course, we are not done yet. So we're just getting started now with heavy duty.
Okay. So it sounds like this track record is incredibly extensive, touching all sorts of tasks, responsibilities, planning scopes, and over 90 hydrogen refueling stations in operation. That's incredible. So would you say that this is one of H2 Mobility's biggest milestones, or what have been the other great milestones, but then also the learnings that have come along this way on the path so far?
Yeah, well, it's difficult to pick out one milestone, and I would rather phrase it that there are many milestones, and depending on which view you take. So, for example, for a customer, from the customer point of view, and customer goes first, each new station in our network was a big milestone. Then on the other hand, if you look from a technical point of view, of course, we did quite a few learnings together with the HRS suppliers, where we did a bigger station, and this will continue. And for us as our team, of course, as the team developed, we started with 0 personnel. Now we have 45. So there were many milestones, and you see on this slide, you see a few impressions on what we have achieved over the last years. And like I said earlier, we're not done yet. So there are many more milestones to come, and I'm looking forward to do so.
Absolutely. And great growth, and congratulations to the milestones, learnings, and success of your team. Now turning our attention a little bit to the greater worldwide picture. Nora, I'm wondering if you could tell us what the worldwide and H2 Mobility hydrogen refueling networks look like at the moment, and what HRS have been built specifically, and what technologies have been used.
Sure. So looking at a global scale, we really see the hydrogen refueling network growing everywhere. You see Asia leading the way here at the moment, also Europe having over 200 stations, and then the US, mainly California, also deploying a lot of stations. Mm-hmm. Zooming into H2 Mobility's network, we have already said that we are the leading HRS developer worldwide, and nobody else has as many stations built and in operation as H2 Mobility. And it's also really special because in Germany, the approach was to build an unconditional network first. And now we are really shifting towards also more the demand-based conditional ramp-up. One other figure we're really happy with is that we have an average availability of 95%, what is really important for our customers, that they get to the refueling station and it also works. Yeah. Looking at the different refueling stations that we have built, the idea until now and the focus was to look at cars, light-duty vehicles, and also buses, some medium-duty vehicles, with our S and M stations. Now, in the future, we are looking more at medium-duty vehicles and heavy-duty vehicles, where we will be building, due to the customer's demand, but probably way bigger stations, up to 4 tons of hydrogen throughput per day. And this is also what we analyzed now in our paper that we will be presenting.
Great. So you covered a lot in that answer and that summary, but it sounds like there's a lot of change happening at the moment. You mentioned an unconditional ramp up to a conditional ramp up. You also mentioned the different sizes of HRS. So I guess the question is, why is this important now with all of these changes happening in the market? And what is the hydrogen demand projection and outlook of the market?
Yes, sure. We really see an intense demand increase over the next decade, really. So until 2030, we see that there will be a demand of 300,000 tons. This is mainly shifting from cars, passenger vehicles, towards the demand driver being heavy-duty vehicles. So in 2080, there will be over 80% the demand in Germany alone coming from heavy-duty vehicles.
I see. Okay. So, Nicolas, maybe you could speak to that demand. So what specifically are the vehicles that will be driving that demand more and more?
At the moment and in the past years, the demand was almost solely driven by passenger cars. And they are driving demand to quite or on a quite steep exponential curve. I just checked, and in the past months, every month we marked a new record in terms of demand. So in July it was 10% higher than in June, and around 70% higher than last year. And by the way, you can follow that live if you want on our website, h2.live. I've just posted it in the chat. But now we are at the turning point.
Okay.
Sorry, I think I was just kicked out for a second. So we are at the turning point at the moment. And as I mentioned before, in heavy duty, hydrogen makes a lot of sense. And the good news is that previously people thought and said that for heavy duty trucks, hydrogen will be a story or will become a story only in the 2030s. Now we see that this can happen much sooner, and it's actually happened at the moment. We think that the heavy trucks will hit the road in higher numbers around mid of the decade, so around 2025. And the important message for us as an infrastructure provider and for other infrastructure builders and operators is that now is the time to prepare. Because as Nora has just shown, in the past, it was more about coverage. It was more about light-duty vehicles, at least in Germany. And to be ready in 2025 for higher numbers and also for a steep ramp-up, we need to decide on what's the right station and what's the right refueling technology. And as we all have probably understood also through the paper, we face the luxury problem that we have at the moment several technologies fulfilling the needs of heavy-duty trucks. But nevertheless, it's, let's say, a luxury problem because we have many options, but it's a real challenge because in the next 1 to 2 years, it should become evident what technology actually should be deployed in what market to make informed investment decisions.
Yeah, definitely. So in general, a lot of HCV are coming, right? Maybe, Lorenz, you could explain for us the difference between refueling a car and a truck with hydrogen and what that means for the infrastructure that is coming that Nicolas is speaking about.
Mm-hmm. Yeah. So over the last years, we gained quite a bit of experience with the vehicles that were on the market and also, of course, the refueling stations, and they were focusing on passenger cars. And so there are several aspects that you need to cover to see the shift from passenger car to trucks. For example, if we start again with the customer, on the one hand side, you have pioneers, you have the early adopters that are starting with the passenger cars. Yes. But now with trucks and larger vehicles, you have a different customer segment, which have different requirements, and this of course also reflects then, and not only in the vehicles but also in the refueling stations. And so again, just a technical detail, if you look at the trucks, for example, with passenger cars, you have tank sizes for the hydrogen of 4 to 5 kilograms, maybe 6. But when you're talking about long distance coverage, then you need tank sizes of 60 to 80 to 100 kilogram, which of course then reflects in different refueling stations. So we need to build bigger refueling stations, and we need to check whether those stations and systems and solutions that were built up and developed for the passenger refueling infrastructure can apply and also can be used for the larger vehicles. And last but not least, this of course also means that you have a different logistics requirement. So you have way more hydrogen that needs to be brought to the selling point and need to be stored. And right now, I mean, we have stations that store 200 to 400 kilogram on that same spot. Of course, if you look at the tank sizes that I mentioned earlier, you need much more hydrogen on the station that needs to be brought there. You need a network. And so there are many aspects that need to be covered that are a little bit different than we have it on the passenger side. Nonetheless, we can build on the learnings and the experiences that we made on the passenger infrastructure side.
Absolutely, absolutely, yeah. And all of these differences, so like you're saying, from the passenger side to the heavy duty side, all of the differences in logistics, in HRS. There's so much detailed information on these topics in the overview that your team has published. And again, as we mentioned earlier, that paper overview is available for download. The link is in the chat. That overview is called Hydrogen Refueling for Heavy Duty Vehicles. It's been published and again is available for download. So please do have a look. Let's focus or dive a little bit deeper into the contents of this overview. And Nicolas, could you tell us in general, what is this overview about? And what was your team's main motivation for publishing it?
So the overview describes the main options to refuel hydrogen in heavy-duty vehicles, so in bigger tank systems. Today we fill tanks of up to 40 kilograms, and heavy-duty trucks will probably need more than 60, even more than 80, up to 100 kilograms. The main motivation, I would say, was twofold. So first, we haven't seen such an overview in the market, and we think it's important to understand what the serious options are and what their trade-offs as well are. You will see in the paper that probably all 4 options can cover the needs of heavy-duty vehicles, but there are some very remarkable trade-offs, and they should be taken into account. Second, we at H2 Mobility, we feel a sense of urgency, I may say. When vehicles become available, the uptake can be quite fast, and it depends then on the availability of a network of stations. And as I mentioned previously, if this uptake starts really to kick in 2025, around that date, then we need to be prepared. So with this paper, we want to accelerate the discussion, let's say, about technology choices, because technologies need to be chosen in the next 1 to 2 years to be ready and on time when the trucks hit the road.
Yeah, absolutely. Okay, and maybe now Nora could tell us a little bit about the process of actually getting this information, collecting all of the appropriate research, and maybe you could explain the methodology that you used to be able to share this information with the audience today.
Sure. Yeah, the goals were already pointed out by Nicolas. I think we asked ourselves a couple of key questions. We asked ourselves, what are really the tangible refueling options for heavy-duty refueling today? And what does the possible station look like? What is the possible layout? What are the advantages and disadvantages? And all of this data we gathered through internal and external expert interviews. We developed a framework to look at each HRS option with the status quo, the vehicle, the HRS side, and then also wanted to assess, of course, the technology with a technology readiness assessment and also looking at the cost drivers. It's important to say that we looked at long-haul applications with a target refueling time of 10 to 15 minutes, and with this high tank capacity with up to 100 kilo of storage.
Right, right. Okay. So the method is clear. It sounds like there were a lot of different input sources to gather all the information, like you said, about the actual technologies, their readiness, their cost drivers, etc. So talking about the hydrogen refueling technologies that you detailed or focused on in this paper, could you tell us about the options from the technology side, and maybe a brief introduction to the different HRS options as well?
Sure. We looked at 4 different hydrogen refueling options for heavy duties vehicles. We looked at 350, 700 bar compressed gaseous hydrogen, as well as subcooled liquid hydrogen and cryocompressed hydrogen. These 4 options we see that are the most focused on right now, and that have the most momentum from OEMs as well as engineering companies.
Okay. And starting with the first technology, so there in the left top, 350 bar gaseous compressed hydrogen. What about this HRS technology? What's the status quo, and what vehicles are driving with this technology?
So currently, we can say that 350 bar is a really mature technology. We see the Hyundai trucks running already in Switzerland with 350 bar, and it is also used by buses currently a lot. But all of this is just for refueling of like not the high quantities that we are looking at, but up to 42.5 kilograms. That protocol is currently under development and will be published shortly. So you can really say that 350 bar right now is available not in 5 years, but it's available like tomorrow. So that is really, really positive. Looking at the challenges, we can say that it has a low energy density and therefore a limited driving range. And this leads into the vehicle design being like challenging if we want to reach higher ranges.
Right.
Looking at the possible layout that 350 bar compressed gaseous hydrogen could have, we would imagine a trailer swap concept that would be a useful supply case. We will look at direct refueling from the trailer into the vehicles and the medium pressure storage so that the trailer also gets completely empty. So that's just one possible layout that we could imagine.
Mm-hmm, mm-hmm. Yeah, thank you, Nora. It seems like all technologies, there are huge benefits, and then, like you mentioned, some challenges and trade-offs. So thinking about the next hydrogen technology, 700 bar technology, I've heard that multiple OEMs are developing with this technology at the moment. So maybe, Lawrence, you could tell us about the second technology option that is described in your team's overview. And again, what is the current status of 700 bar technology, and specifically which OEMs are developing it?
So for me now it's a little bit easier because I can simply say it's basically what Nora already explained to 350 bar, but of course it's double the pressure. So there are quite a few challenges that come along with it that you don't have with 350 bar. As you can see, there are 2 OEMs working on it, Nicolas and Toyota, for example. And what helps in that process is that, of course, the 700 bar technology has been proven in the passenger segment. And so you can have all the learnings. And in the passenger segments, we did have the advantage, or do have the advantage, that it was an industrial standard all over the world. And this is, of course, something that you want to build up on. And you have also the advantage that you need less space compared to the energy that you transport, so to say, in your tank system. And but there are also, of course, some challenges that come along with it. As, for example, you would need to have communication, most likely, so that the pre-cooling of the hydrogen can be done. So the pre-cooling, again, a technical detail, is most likely necessary because you want to have the short refueling times and you want to avoid an overheating of the tank system. And so there again, communication is something that also has been or is implemented in vehicles and HRSs right now for passengers, but you need to transform it to the other segment. And on the other hand, you have the benefit that you can carry more hydrogen than with 350 bar, and thus carry or cover a longer distance with those vehicles. We do not see a prototype yet on the road, at least officially not. And this, of course, means that also on the HRS side, we do not have any stations yet implemented to see what does it actually mean to refuel 80 kilogram, for example, pre-cooled in a vehicle on one swap. So there are a few challenges, and you see on this slide that basically the layout will be similar to a 350 bar, but you need different compressors that do compress higher. And of course, this means that you have also components that need to last for a higher pressure, or that need to cope with a higher pressure.
Certainly, yeah. So for both of the two technologies that Nora and yourself have detailed so far, lots still to discuss, lots open on the table, but it's clear that there are potential advantages and potential challenges to each. Turning to the third technology, there's been an announcement from Daimler that they'd like to start customer testing with SLH2 with the Gen H truck by 2023. So what's new with this third technology option? Maybe Nora, back to you. What's the status quo and what should the audience know about it today?
Sure. So yeah, Daimler and Linde are really focusing on subcooled liquid hydrogen at the moment, which has the advantage of having a higher volumetric energy density compared to gaseous hydrogen. It is an advancement of the LH2 technology that has been developed before, and it would allow higher onboard capacities and high flow refueling for long range, for example, logistic applications. The challenge right now is still at pretty much an R&D stage, and you probably all know about the boil-off challenge. Daimler is saying there that they have reduced with the subcooled liquid hydrogen the boil-off significantly, and if you have a use case where the vehicles are running a lot constantly, then the boil-off is not so significant anymore. Looking at a possible refueling station that we imagine, we can say that layout and the footprint of the station would be a bit smaller than the gaseous option. We would have the LH2 trailer, supply storage, and a pump container. And yeah, this is this station doesn't exist yet, but this would be one possible layout.
All right. And let's go back to Lorenz to talk about the last technology. So cryocompressed hydrogen technology aims to combine the best of both worlds. What does this mean, Lorenz?
And again, I can say it's similar to what Nora said, but not. So in the end, it is using liquefied hydrogen, but also putting it under pressure. So from a physical point of view, this means that you can have the highest energy density to use. And of course, this brings also some advantages with it. So you have, in that case, the experts tell us that you need no data communication between vehicle and HRS, and you have a lighter tank system that you can use compared to subcooled. But still, there, of course, are all the challenges or trade-offs. We have not seen a vehicle yet. They will be announced, like it says on the slide, they will be announced end of this year, maybe on next year or 2023. And of course, this also means that there are no hydrogen stations yet available that we could check, test, etc. So in general, it is still at a very early stage. And if you look at the layout, also this, we assume it will be similar to subcooled hydrogen, which also means that it is more compact than you have it with a gaseous hydrogen. But it also means that you are relying on only few sources of hydrogen and the supply chain that comes along with it, and thus dependent on it, even though there are also solutions that you can combine it with gaseous hydrogen. Like I said, we are looking forward to see also in that case prototypes on the vehicle and on the HRS side.
Certainly, great. So we've heard now about these 4 technologies that are detailed in your team's overview, and they're all at different stages of development. So now we'd like to hear about your team's assessment of the readiness of each of these technologies and the readiness of each HRS technology. And maybe Nora, you could tell us also about the methodology that you used to assess this readiness level.
Yeah, sure. Of course, we were interested in assessing the different technologies, and therefore we looked at it in 4 different dimensions. We looked at the supply chain readiness of liquid versus gaseous hydrogen supply. We looked at the vehicle storage system readiness, which is also like the tank readiness, and then the infrastructure side, the HRS readiness, and also the maturity of standards. I will not go into every detail right now, but I think overall we can say that 350 bar and 700 bar are closer to commercialization than CH2 and SLH2, which are more in the idea research and prototype stage still. But the details you can read also in the overview.
Yeah, absolutely. So if you're interested in more information about the technology readiness levels, please do follow the link to read the overview in the chat. So in general, Lorenz, what could you tell us about the main results that you've been able to derive from this overview?
Yeah, for us as an infrastructure provider, we can point out that all solutions that we examined are feasible. So that's full stop. We can do it. And this overview should give everybody who reads it a comprehensive and pragmatic view on what is out there. But at the moment, we try to show what are the trade-offs, what are the advantages and disadvantages. And by this, hoping that this can be a starting point for discussion, not only for us internally, of course, but for everybody who's involved. And so that we gain the speed that we need to be fast in deciding which way to go and where to invest and which infrastructure we want to invest in and build up, so that sooner than later we have those trucks on the road and they can be refueled on our stations.
Definitely. Yeah, now is a time for decisions. So then, Lorenz, what do you think the next steps will be that are needed for a fast, efficient rollout of the hydrogen refueling network? How can we come to these decisions that are so needed?
Mm-hmm. Well, we have seen it with the network for the passenger cars. It all works if everybody works together, and we are a little bit repeating history now, just on a different market segment. So what helped us to be successful was that everybody was walking in the same direction and working together. So I think if we use this approach and the whole industry comes together, we build partnerships that last and that are driven to get the right solution out there, then this definitely will be a major or important step towards an infrastructure for heavy-duty vehicles. And we need to get prototypes rather sooner than later on the road, and of course also HRSs on the site, on the station. And there we need to have a very close collaborative working together, OEMs and suppliers, and we as operators and other operators, so that we can collect as many data as possible early, evaluate it, and then make the decision which way is the most efficient or most economic, and from a broader picture, which way is the best to go, because this infrastructure cannot be built overnight. That's what we also said for the passenger infrastructure, and it does need time to get everything set up and get from scratch to commissioning and operation. It will take some years, and this is something where we need to all work together and push so that the progress can continue.
Yes, absolutely. Collaboration, data sharing, and partnerships. That's a great and needed message. So looking towards the future, hopefully a more collaborative future, we've seen the different options for a hydrogen future. And Nicolas, then here, what is H2 Mobility's position on the future development of the technologies?
So our first message is that we need to be fast. 2025 is tomorrow, and if in 2025 we want to have established a basic network of stations, then let's say building the stations takes around 3 years. That brings us to 2022, where we need to start the whole thing. And as I said, at the moment, there are just too many options on the table. Second, I would say that we at H2 Mobility, at the moment, we are agnostic. So we are not saying that this or that option is the right and only one. However, what is important to us that the trade-offs, especially the ones we face on the infrastructure side, are known and heard. So for instance, Lawrence has described a 700 bar as being a bit more complex. You need probably more energy to compress. You need the communication, as you mentioned. So OEMs and customers need to be aware that hydrogen at 700 bar will always be more expensive and significantly more expensive than hydrogen at 350 bar. Does that outweigh the advantages, let's say, or the disadvantages 350 bar has? Because you get longer range with less space on board, with probably less weight on board. These are the decisions or the discussions which need to happen. And there we want to play a role to be fast and to be prepared.
Right, right. So to be fast and to be prepared for the future and future development. And what do you think H2 Mobility's role will be in this future development?
Well, in simple words, we will build and operate hydrogen refueling stations for customers. So we will continue to provide the cleanest of all fuels, I may say, where it needs to be provided in the right quantities. I think we will continue pretty much what we do today. So directly enabling the transition to hydrogen by building infrastructure, and let's say indirectly enabling it and supporting it by initiatives like this overview here, like the discussion we are triggering and trying to structure, but also by providing our knowledge to others so that their learning curve can be steeper than ours and less painful sometimes. Okay,
so a less painful learning curve is, of course, what we're all trying to achieve for the future of hydrogen infrastructure. And in terms of predictions, looking ahead, what do you predict hydrogen refueling will look like in 5 years, in 10 years' time?
I think in 5 years, hydrogen refueling will have become simple and convenient. And you may be surprised that I'm saying that because, of course, I would like it to be simple and convenient today already. However, I think there is a lot of room to progress. Just to give you 2 examples, you have seen the hydrogen dispensers on one of the slides. I don't think that the future will look like this. They are heavy. They don't look like future. The look and feel is not what we envisage to be. There will be more digital, there will be much more convenient. And second example, payment still happens by using a plastic card. I think in the next years, we will see much more integrated ways to pay at the pump. We are exploring that at the moment, by the way, with mobile payment options, with using the smartphone, but with also using the car directly. So I think there will be great progress in terms of simplicity and convenience. And in 10 years, I think the biggest and realistic advantage or advancement will be that we will have green hydrogen. Green hydrogen will become a commodity and will have become a commodity in 10 years' time. So we will have found ways, and there, by the way, is a similar discussion happening on the transport side. What is the right way to transport high quantities of hydrogen over the long distance? Similar discussion, similar state than where we are with the current discussion here about refueling it to heavy duty vehicles. So that will have to be decided. And in 10 years' time, I envisage that we will see green hydrogen at the pump at affordable prices.
That is certainly the hope and the vision. So thank you so much to all 3 of our speakers today for that very informative and insightful presentation. And again, to reiterate, that overview has been shared. If you'd like more details and you're interested in more information, we do encourage you to read. On that note, we would like to conclude the presentation part of the webinar and thank our speakers again for being here today. Let's transition into our Q&A session. Lots of questions were coming in during the talk. So now I will hand it over to Silke from Mission Hydrogen to answer those questions. Thank you, team.
Yes, dear Erin, dear Mobility team, dear Nicolas. Well, as I said to Sibylle before we started the webinar, we will definitely reach the question break even that we ever had since Mission Hydrogen is sending. And yes, we reached it. Dear audience, thanks for your questions. We have reached over 120 questions. I'm kidding because this is, well, we can do the Q&A the next 2 hours when I look at the number of the questions, but for sure, we will pick out the most interesting questions. We did that in the background while the show ran with Erin and team. So we will do our very best for sure today. And yes, as always with Mission Hydrogen, and I think also with Mobility, if there is something left afterwards in the next 35, 40 hours, then come back to the Mobility team and you can discuss that in parallel. So I have to scroll a little bit today. So I do my very best to bring you the best questions here. Dear team, I will post it to you. I will talk to you and you know the best who will answer the question. Okay, are you ready, Nicolas, Laurent and Nora? There you go. Q&A starts right now. Richard Chandros asks, could you please explain the need for pre-cooling in more detail?
Lawrence, would you like to pick that one?
Sorry, I didn't follow it. Can you repeat it again?
Again, could you please explain the need for pre-cooling in more detail?
Okay, basically, of course, I'm not diving into the complete details, but if you put high pressure gaseous hydrogen in cylinder, and the tank cylinder, and it heats up. And the cylinders itself, they have a certain temperature until where they can be filled. And if it is over this temperature window, then it might do harm. And for that reason, the OEMs set a temperature of 85 degrees. Now I'm lost the word. And to still have the fast refueling times, you pre-cool the hydrogen prior to refueling it to the car. So that allows you to have a faster refueling time, that it cools down the hydrogen itself, and thus also the cylinder. And if you want to have huge or larger numbers of hydrogen or amount of hydrogen that you refuel, then pre-cooling will be one of the options that you need to consider. Otherwise, you have long refueling times.
Okay, next question. There are two questions. I think they are. We can pack that together. Krishna Reddy is asking: is there a heavy-duty protocol under development? If when can we expect that to be released? And Julio Garcia adds: is there a revision of SAE J2601 on the way?
Shall I?
Lorenz, would you like to start?
Yeah. Like Nora said earlier, for 350 bar, we are working on it right now with all the partners, especially all the Clean Energy Partnership. So their OEMs and suppliers, etc., are working together. For everything above, so this only goes to 42 kilograms, and for everything above that, it is still in progress. So globally, there are people, smart people, engineers are working on it. So of course, this is one of the needs that we have a protocol that also covers the larger tank systems. And this will also mean that on a global scale, the SAE will be reviewed and extended so that it also covers the larger tank systems.
Okay, Sven Geitmann is asking, will hydrogen trucks have an impact on fuel cell cars? Will there be a ramp up for hydrogen cars because of better hydrogen infrastructure?
Nicolas, you're mute.
Just pressed the wrong button, sorry. I think the short answer is yes. So what we have seen is, or we are seeing, is a lot of momentum on the truck side. So one could be inclined to optimize stations only for trucks. As you have seen in the overview, we really think that the truck stations should also take into account lighter vehicles and the refueling of those vehicles. And we are convinced that this is a good idea. So in all our plans, we take into account when we choose the location and when we determine the technology that, let's say, on the back of a truck refueling infrastructure, we also roll out an infrastructure which actually can serve lighter vehicles, thereby helping, let's say, with the truck momentum, also the other vehicle sizes to thrive, let's say, and to ramp up in the next years.
And if I may add, if you, for example, look at garbage collecting trucks that are hitting the road right now, they are also using the passenger protocol and thus can use right now already our network. So there will be also a market for medium duty vehicles and for garbage collecting trucks that are relying on the passenger infrastructure.
Okay, where will the first heavy-duty hydrogen refueling station be in Germany?
Well, I would simply say wherever there's a demand. So when we look at the future, of course, all the stations, they need to be also viable on an economic point of view. And so what we need there is we need to have partners that invest together with us, because we as H2 Mobility have built many stations and are operating many stations. and it only works if we have partners that make sure that there's enough demand, because otherwise we have stations sitting around and no vehicles are coming. So wherever there's enough demand, we will build. So we are flexible. We have been building stations at every federal state in Germany, and whoever comes first with the most interesting concept, I'm happy to discuss.
You could also be more optimistic, Lawrence, and say it's already there. I mean, it all depends where you start defining that heavy duty actually starts, right? So if you go to our app, H2 Live, you can now filter for 350 bar, and there you will see that there are a number of stations already allowing bigger quantities than 350 bar at least. And some people even call the garbage collection truck heavy duty already. And it's an interesting example how we, let's say, tweaked optimized the passenger car infrastructure to also allow refueling of heavier vehicles, because the protocol only allows up to 10 kilograms. The technology sometimes rather up to 7-8 kilograms. So we have together or work together with the OEM providing these trucks, and they have simply installed 2 tank systems, each 8 kilograms. So thereby you need to refuel twice, all right, but you can use the existing infrastructure. So I think it's happening today, and the transition is rather gradually. But if we're talking about the L-sized stations, then it's probably going to take 2 more years. And then, as Lauren said, where the demand is, will the station be?
And I can add, before I come back to your 2 words, partner and demand, I want to go to the chat because Alexander Meyer from the PIN 21 project, he tells us the first station for trucks will be in Passau, I can tell you. And another thing is from Rainer Michel in German. It was really interesting workshop, but can we please repeat it in German? This would be a wish. So it goes to HM Mobility. Mission Hydrogen is always willing also to bring webinars in German to the audience for sure. Dear Michel, we will discuss that, and then you will stay up to date with the newsletter. And if we will also bring this to you in German. There you go. Partner was the word. Will the strategy be changing for HM Mobility because Hyundai has joined as the 7th shareholder now, Nicolas?
No, is the short answer. Hyundai joined, and I'm happy that they did. Also because they are fully supportive of our strategy and will help me personally, let's say, push it with all the other stakeholders. So what is our strategy? Without speaking about the details here, but as I mentioned previously, we are convinced that hydrogen is and will become a solution for all vehicle sizes. And Hyundai is a very good example. They are developing all these vehicle sizes and pushing it. So we all know the Nexo. Soon there will be a van. Then there are buses, then there are the trucks, the action trucks, which Nora has shown, and they're also developing a semi-trailer tractor truck, so a really big one. So they stand for hydrogen as a foundation for the future energy system, as a foundation and an important fuel for all vehicle sizes. By the way, they also stand for the battery. So hydrogen, or Hyundai is probably the company in the world who has most battery models, so purely battery models and hydrogen models in their range of vehicles. And therefore, they really reflect our deep conviction that both solutions will be complementary. And therefore, I'm very happy to have gained them. And we just had the first shareholder meeting, by the way, 2 weeks ago. And they had a presentation and really inspired all the other shareholders as well with their speech.
There you go. So we come to the colors. Kurt Seidel, may I ask, which is the color of the hydrogen you are providing in your filling stations?
All right, let me start that one. I mean, again, it's about definitions, but I think if we think in green being purely green from green electricity, for instance, blue being sort of CO2 neutral, and gray being from steam methane reforming and natural gas, then around 1/3 of our hydrogen is blue and 2/3 are gray. Whereas we have to add that from these 70% gray, another half or so is from byproduct hydrogen. So it would otherwise not be used at all as a fuel. That is the current status. We see that changing, and luckily the supply of green hydrogen is picking up. In the past years, it was really challenging to find a few kilograms on the market. But now this is changing. There are lots of production sites being built, also bigger sites being built. And as soon as we can supply our stations at affordable cost with green hydrogen, we will do so.
And there I would add that we do have already a few stations that are also hooked up to local electrolyzers and also other operators, as GP2 showing that it is possible. And we need more of those projects in general, more sources of green hydrogen, because we all know that in the long run, it needs to be green hydrogen.
Yeah, and if I just may add, I think it's really important that we increase the share of green hydrogen, and we really want that. The availability has really been the problem until now, and also the transport of it. So because normally the hydrogen is transported until our stations, and yeah, we're looking forward integrating also more green hydrogen supplies.
Okay, there you go. Nico Bocam, how does H2 Mobility coordinate with other European countries on the rollout of HEV hydrogen stations? Heavy-duty fuel cell trucks for full functionality for truck fleet operators will not stay in Germany only to move freight and will need to be refueled outside Germany.
I start and then Nicolas can continue. So also there we can look in the past, a big amount of the stations that we built up has been funded also by European means, and therefore we know how it is working together with the other European partners. So the EU is pushing also exactly this topic, and it is perfectly right that, of course, especially with heavy duty, you cannot only look at the national solution. So it needs to be a solution that is goes beyond borders, and there are European projects being set up. So, for example, the IPCEI funding program. So this is one mean where the EU will strongly push in the direction that you have cross-border corridors that can be used by heavy duty.
Okay, dear H Mobility team, if you see one of the last questions that are now coming in the chat, feel free to interrupt me and bring something out from the latest questions. I will go on with those we have marked during you were speaking. Let me see. Gary Wayne, have the hydrogen refueling station sector agreed on a style of the refueling nozzles and receptacles?
On the passenger side, yes. Like I mentioned earlier, they're lucky enough we have a global standard. And for some of the technologies that are in the overview, you can also make a tick mark. But for some others, they need to be developed. So this is also one critical equipment, of course, that needs to be looked into. And yeah, so that's how I would state the current status.
Okay. Humay Sultanpuri. Daimler announced that that they will develop liquid hydrogen fuel at cryogenic temperature, technology. However, it will store more fuel quantity. But how do you see this energy efficient to keep hydrogen stored at minus 253 degrees Celsius?
Well, I don't think that efficiency is a problem here. I mean, efficiency is overweighted in all these discussions. Hydrogen is very efficient. If you look at the whole chain, power is only one resource in the life cycle, let's say. There are many other resources where hydrogen has a very low footprint, being in raw materials or others. if hydrogen is produced at a bigger scale, then the liquefaction will not be a major issue. We are talking maybe about 10-15% more kilowatt hours per kilogram of hydrogen as input energy. So we don't think that this will be a big issue. We welcome very much that Daimler is very ambitious and showing that, well, we did not reach the end, let's say, with the established technology. So that is very good. We need to collect more data because at the moment we simply don't know how well these things will work. And we can say that in our very practical operational life, we have learned a lot and we have faced a lot of surprises. I used to say that operating 700 bar stations is the Champions League of hydrogen refueling because it's very complex. We have managed that well. There we have a lot of data on the 350 bar and 700 bar side. We're still lacking data on the liquid side, but generally speaking, liquid is a very promising solution, being it in the supply chain as a transport vector or probably also in the tank of vehicles.
And there I would add that we do also, because maybe not everybody knows, we do also have some stations in our network that already use liquefied hydrogen as a storage. So we have already the experience with the supply chain that's prior to the HRS and also storing the hydrogen. And there with the current technology already available, you can do a lot, which the part that will be new will be then putting the liquid hydrogen in the vehicle. So that's where you need to gain experience.
Yeah, maybe let me point out one bigger challenge that I see is the liquid hydrogen supply chain at the moment. We don't have that many liquefaction plants in Europe at least. So if we want to scale the demand, we really have to also scale the production. Import, of course, also a lot talked about, but currently like the volumina have to increase.
And there fits a question from Christian Machens. Do you have response from the large freight companies?
Well, a huge interest in the technology. It just the interest gets just less or more conservative if we speak about cost, because at the moment the availability of affordable trucks is a big issue. So in the past years, when we have spoken with haulier companies, the interest was and is overwhelming. It's just that we need that the vehicles were not there. Yeah, but maybe I let Lawrence comment on that because he's responsible as well for the business development in our team.
Yeah, I would put it in similar words. So there are quite a few companies out of that sector that contact us and they want to get started. So the talks that we have are promising. And now we just need to have the vehicles. We also need to have the stations that are required. And then, we can start. And I mean, if you look at Switzerland, you see that it is possible. And so something similar or maybe with a different technology can also be done in Germany.
There you go. With over 1,160 people in such a live webinar, we have a broad range of questions, very basic questions right now for you. Comes from Ed Krüger. How many stations do you have now?
So in general, it's must be 90. So 91 in operation, 5 in Austria, and 86 in Germany. And of course, there will be a few more coming this year. But not only by us. So we are very happy for every other station that hits the network and that is available for customers.
And if you want to see the actual live statues 24/7, you go to h2.live, right?
Thank you, Silke. I should have pointed it out.
There you go. Here it comes. h2.live. The link is in the chat, dear audience, and we will go ahead. Nora, I think you talked about Europe, and for sure all the other speakers also. Perhaps the next question from Oliver Schneider fits here. Why is the network rollout in Europe so slow?
Yeah, like we're It's not an easy question to answer. I mean, like, we've been actually speeding up the rollout, I would say. We've been building a lot of stations in really little time. And we need like sometimes over 1 year to plan and build the station. But it's really due to the demand now. If we could increase the demand, I think the rollout of the stations would be way more speedy. And we are also looking into deploying more stations. But every country kind of has their own approach in Europe right now, and we have to harmonize that. And in Germany, the rollout has been not so slow and has continued to be faster.
Okay, I think the next one is for standardization from Deepak Tiwari. Our EC79 and ECR134. So different codes are being formulated. This may bring confusion for suppliers to make their compliance.
So they need to pass because I don't know the technical details that spontaneously, but yeah, I'm sure that it has been covered with what I said earlier, that globally there are people working on it. They're putting their heads together, and of course it will also be that it will be standardized, because that will make lives easier also for the suppliers and also for us to order it. And it needs to be, of course, according to all the regulations that are in place. And there I would say can copy and paste at least the methodology from what has been done in the passenger cars, because that has been outstanding, that globally we had with the hydrogen protocol, etc., already a standard, where other technologies did not have a standard yet.
Okay, and now there are two questions for slide 8. This is from Jörg Adolf and from Tom Shaw. When I look at slide 8, I wonder where is the size? Is this either size category XL or the other one? What is the HRS technology on slide 8? Should we bring it to you?
Slide 8 is about the specs. Nora, right? Would you like to start?
Sure. On slide 8, we've shown like the categories that have been defined by us until now, from SM, L, and XL, double XL stations. But of course, it needs to be said that this is an ideal world, and we are going to be building stations based on customer demand. So if there's more vehicles that need to be refueled, we can adjust that. But these are the general sizes that we will be looking at. And we actually had a lot of discussion about to call it XL or double XL, but in the structure of looking at the maximum hydrogen throughput from L being 1 ton and then going into 4 tons, we would call it double XL right now.
Here we go.
Exactly.
And I think the second part of the question was which technology. There is no particular technology behind L and double XL. So M, of course, M is 700 bar combined with 350 bar. So 2 nozzles, 2 pressure levels. L, and you could add here XL as well if you want. They are not defined yet. There are no stations in Europe, at least, of this size. And we have defined double XL because we think this is sort of the end game solution for really big quantities. And whether this is a gaseous station connected to a pipeline or a station with liquid trailer swap supply plus liquid at the nozzle, or 700 or 350 bar at the nozzle, it's not defined yet. It's more a functional approach to make clear as well what we are talking about when we show the station layouts on the further parts of the overview.
Okay, going back to Jürgen Meereis, how many of the filling stations of H2M in Germany are suitable for heavy-duty vehicles requiring 350 bar, and how many are just suitable for passenger cars 700 bar?
Nicolas, do you still mute?
Let me just show the app here. I mean, if you open our app, then you see the 90 plus stations Lawrence just mentioned, and then you have a filter. You can switch to 350 bar, and the short message is at all stations 700 bar refueling is possible, up to 6 to 8 kilograms, and with the trick I mentioned previously, which we use for the garbage collection trucks, that you simply use 2 tank systems. You can even refuel heavier vehicles than passenger cars at the 700 bar stations. And then at the moment there is a set of close to 10 stations allowing as well 350 bar, so up to 40 kilograms. And this is growing, and you can observe it by just pressing the right button on the app. And
you can see here, the app is working. So for
and
those
I can see, Silke, you don't have the recent update. You need to go to the App Store because you don't see the filter yet.
Yes, I searched for it right now. Thank you, Nicolas. You can see, well, the app is not doing that on its own. Well, for sure. So, dear audience, if you have such an old version like me, then go to the App Store and get your latest version of the app. That's perfect. So let me see, next one. Osvaldo Velasquez, did you foresee higher working pressure than 700 bar in the near future?
Nicolas, is still mute?
No was the answer. We already think that 700 bar is challenging enough. We wouldn't open another 5th option on top of that.
And Niam Conroy, is there a plan ever to connect these stations to the gas grid?
We have already, Lawrence, right?
Yeah, we have already one station connected, and this will, of course, be an option when we are building up, and this is not our job at least, but it will be done in parallel by other companies and organizations that they're building up on a hydrogen pipeline network in Germany. And of course, I would like to hook up to this wherever possible, just to also make the transport or logistic topic easier achievable than rather shipping it by trucks through Germany.
And that is a good example of the momentum we are seeing, because we see tremendous momentum all across the place around hydrogen. If I remember, like 4 or 5 years ago when I started, I was approached by, if I remember correctly, 3 gas grid operators and their managing directors, and they asked me whether we would buy their hydrogen. They described where they were at. Everything was on PowerPoint and very theoretical. And now we see very specific projects. We see investments in pipelines in Germany, and we will see testing of pipelines soon. This is one example where there is a lot of progress. And of course, as Lawrence mentioned, if we can connect to a pipeline, then the supply becomes rather straightforward, with one big question mark, which is the quality. Because there again, we need to agree on a standard, and pipelines probably will not carry the standard we need. Therefore, then we would need to purify the hydrogen on site, which can again be relatively costly. But as I said, a lot of momentum, and the right topics are being explored. And we will see a lot of progress. And I'm sure this was not the last webinar about this topic. And it's just a starting point, right? And we will bring it on.
And you can see the hydrogen field is really agile. Is that agile the right English word? Because now I have the latest version with 700 bar and 350 there. And you can choose it here, and then you have it. This was the point that Nicolas told us, and I will go ahead with the next questions. We have about 7 minutes left, so can we make the next 7 minutes, dear team? Okay.
We will.
There you go. Tom Wagoner. Which manufacturers are producing the most heavy-duty vehicles using hydrogen?
Nora, I think that's one for you.
I mean, they're looking at Hyundai right now. I think they're really now going big into the market. And I think they're going over all vehicle classes, which is really interesting. And also looking at Toyota, of course, as well as more focusing on just heavy duty as now Nicolas and also Daimler. But I think with Hyundai and Toyota, we have really strong OEMs coming into this market, which will deploy all vehicle classes with hydrogen.
It's another example of the momentum. I mean, I previously mentioned that we see a growth rate of 70% compared to last year at the moment. 70% is quite steep, right? It's still at a relatively moderate level in absolute terms, but whoever does the math with an exponential curve at 70% knows that this will change very soon. And the biggest, or let's say the highest number of vehicles in terms of heavier are indeed garbage collection vehicles. At 9 stations, while we speak in Germany, those vehicles have already been deployed. So at 9 stations, you can see in Germany very silent garbage collection in the morning. And I always like the colleague who came, or like to remember the colleague who came with, well, a lot of passion in his voice the other day into the office and said, wow, this morning I stepped out of my door and I saw the garbage collection truck, but I didn't hear it. It's so different if the compression of the garbage doesn't happen with the diesel engine. We all know that noise, but it just happens very silently. So that is one of the applications we see. And as Nora mentioned, probably Hyundai is most advanced in terms of scale at the moment and size of the production.
And do you have your glass bowl with you? Because now there comes perhaps a question from Michael Epler. The mostly cited source I know talks about 140 hydrogen stations required for heavy-duty vehicles in Germany. How many do you expect will be required, and how many in the whole of Europe?
Wow. Let me start, and Lawrence, you can add the correct numbers. Well, you need a glass bowl and you need to make some decisions first. For instance, if those heavy duty stations will be liquid stations, also refueling liquid hydrogen, then obviously the trucks will need fewer refueling stops. It will be more comparable to the current diesel station network. And then you don't need many stations, actually. They just need to be in the right spot. We are talking about, well, a few dozens of stations to cover Germany and even the surrounding markets. If we talk about 350 bar on the other end of the side, then trucks will refuel more often, which is also thinkable. It requires some process changes, but if the fuel gets cheaper, the haulier companies may be inclined to think about it. So it really depends on the technology choice, and that makes clear as well why this technology choice is so important, because the network planning changes. The network planning changes if trucks run 1,000 or 1,500 kilometers on one refill, or if they need to refill every 500 kilometers. Therefore, I would say, ask me again in 1 or 2 years. The one thing I can say, there will be much fewer stations required than today. First, because we see a complementary solution with the batteries as well. And second, because, well, there are, I would say, too many conventional refueling stations today, just speaking from a capacity standpoint, that has historic reasons, but we will not see like 15,000 stations again in Germany, for instance.
There you go. So, longer term strategy. Later than 2030, how do you view hydrogen supply to the stations, mainly still via truck, liquid gases, or via electrolysis, or directly connected to a hydrogen backbone?
Lawrence, you want
Yeah,
to
I think
start?
we can basically hooks up to what Nicolas just said. It all depends on the choices and the use, or the use case which technology will be used. And for that reason, it will answer itself in a certain way. If it's tending towards liquid hydrogen, then of course you need a different set of logistics and production, rather than when you have the focus on gaseous, where you can work with local electrolyzers and maybe also with pipelines. So it's difficult to tell, and I think we will have examples hopefully soon to see what are the benefits and the disadvantages, and then in parallel with the decision what technology to focus on. This also will evolve in how we cover the logistics.
Yeah. The good news is that we have a very good solution at hand for the next years, which is the trailer swap, right? This is I mean, I always say don't underestimate the potential of a trailer. If you use the current capacities and technology, then you can transport 500 even to up to 1 ton per gaseous trailer and up to 4 ton per liquid trailer. And the transport cost is not so high anymore if you really use this capacity. And the step change happening at the moment is to switch from stationary tanks to trailer swaps. And we see that we don't have that yet at our stations. We see that at the station of GP Joule in Germany, for instance, or in Switzerland. This will bring us throughout the next years. And then the big question for the next 10 years and beyond is, will it be more direct pipeline connections, or will it be more liquid? I think those are the two key pathways where, well, it will be decided whether it will be one or the other, or what weight each will have.
Paul Jenne, what is the average cost of kilogram hydrogen at the station?
Finally, the price question. Very easy to answer for Germany. Nora, what is our price at the moment? Remind me.
So 950 at the station for the consumer.
On all H2 mobility stations, we must say.
Yeah. So the average is very easy to calculate. However, we have to say that, of course, for bigger customers, like in the conventional fueling space, there may be rebates. So that is the pump price. And then depending on the quantity, there are sometimes different prices as well, depending on it.
Okay, there you go. So now it's 5:30 here in Germany. Oh, well, we have about 60 questions or something like that left, but for sure, the questions were doubled or tripled sometimes, and I think we have brought a lot of answers to you, dear audience. A very last question, Nicolas, does H2 Mobility also build stations for third parties and other companies?
Since Nicolas was kicked out, I will answer this question, since it's in my department anyhow. So yes, we are providing our services also for other customers. So not only with our own money where we invest, but also for whoever wants to have public stations can reach out to me, and we can provide services, especially in the first phase when you have to decide which concept, which station is the most convenient or the most relevant for your use case. I have a business development team sitting out there that has, of course, gained over the last years a lot of experiences. We have tools and methods how to develop those stations. And then if you have the technology set, then you can go out to the market, and we can help you also by with the permitting, with the funding, with the implementation of the station, and last but not least, of course, also with the operation, because there, with the experience, we have a very skilled team all over Germany that is operating the stations, and we are happy to help new operators in the market to do the first steps, because every station more, and I keep repeating this, is a station more for our customers.
There you go. Feedback overview in one word at h2-mobility.de. This is your way to give the feedback to H2 Mobility. I will now say my last words for today and then give over to you, to the co-host of today, to H Mobility. I'm not sure if Nicolas or Erin are doing the last words here, but I'm pretty sure you know that. Dear audience, dear hydrogen fans, dear Mission Hydrogen fans, after the heavy-duty transport discussion of today's webinar, I'm now inviting you for September 8. This will be a webinar with our founder, David Wenger, and he will bring to you his 100 days of customer experience with his new Toyota Mirai. So if you want to know how successful or not it was in the first 100 days, then just step in, and for sure with our newsletter you stay up to date. With the next topic we will bring to you for sure weekly here with Mission Hydrogen. Thank you, big thank you to the mission, to the hydrogen, my gosh, to H2 Mobility and team in the virtual stage in the background here for your engagement today. And I'm really sure a lot of discussions will go straight afterwards. And dear audience, feel free to post your questions to us. We will forward it or directly contact H2 Mobility. Nicolas, do you want to tell the last words?
I can. I'm already trembling because you mentioned David's feedback. I'm sure he's a very critical customer. I mean, I know that. So looking forward to that. Thank you very much. I'm really amazed by the interest, and I mean, it confirms that we are living in an important and decisive period regarding hydrogen. I personally, I'm happy that I haven't been in hydrogen 10 years ago, because it would have been too slow and too everything for me. I'm very impatient, and now I see it happening, and we are in the middle of it. And I'm really pleased that we can engage and share knowledge across the globe, basically, and thereby, well, inspiring and really bringing other projects in other countries forward as well. Thank you very much, Silke, for hosting it. It was a pleasure, and I'm looking forward to the dialogue and to our next webinar.
Bye-bye.